Okay, next topic is topic 10.4, and now we're going to be subtracting fractions with unlike denominators. So if you remember yesterday we worked on adding fractions with unlike denominators. And the main thing that you always need to remember is you cannot add or subtract fractions until the denominators are the same. You have to have like fractions in order to add or subtract them. So yesterday when we worked with adding fractions with unlike denominators, we had to find a common denominator or a like denominator before we could actually do the adding. We're going to see the same thing today when we subtract. So when I look at 2/3 minus 1/4, I know there's nothing I can do with this problem until I find a common denominator. So let's just kind of look at this problem. The first thing I would need to do is figure out what do 3 and 4 both go into. And I like to put it underneath it just because it helps me line things up. Remember, if all else fails, multiply them together. 3 times 4 is 12. I know they're both going to go into 12. So I'm just going to go ahead and make 12 my common denominator. And remember, this is when I ask myself, how did I get from 3 to 12? That was times 4, which means the numerator has to be times 4. Remember, we're playing fair. Now, 2 times 4 is 8. So we know that 2/3 and 8/12 are equivalent fractions. They're the same amount. How did I get from 4 to 12 when I changed it? I multiplied times 3, which means I have to multiply times 3 right here. 1 times 3 is 3. Now, here is my problem. This takes us all the way back to Monday when we learned in class how to add and subtract fractions with like denominators. We now have like denominators. Now it's very simply, we bring our denominator over and then we just subtract. 8 minus 3 is 5. So we know that 2/3 minus 1/4 equals 5/12. Now remember, I told you this 9 weeks. One of my biggest things I want us to work on is always making sure our numbers, our fractions, are in simplest form or lowest terms, or that they're reduced. When I look at 5/12, I know 5 is prime, so there's nothing else that can go into 5 but 1 and 5. So I know that this answer is complete. 5/12 is as low as that number can get. Okay? Let's look at another problem. This is going to be another quick lesson because we're basically doing the same thing, just with subtracting. Okay, 6 and 2 are my denominators. They're different, which means I have to wait until I have common denominators before I can even think about subtracting. Now remember, I said if you can't think, or if you can't figure out a common denominator, you can multiply them together. That would be true here. You could do 6 times 2 is 12. But when I look at 6 and 2, I know automatically that 2 goes into 6. So I'm going to make it even easier on myself and make my common denominator 6. What does that mean for me? That means I have no work to do right here. And I love it when that happens. Okay, how did I get from 2 to 6? It was times 3, which means I have to do times 3 here. So 1 times 3 is 3. Now, 1/2 and 3/6 are equivalent fractions. Now I'm ready to actually do my subtraction because I have like denominators. Just go ahead and bring it over. 5 minus 3 is 2. Now, in this fraction, these are both even numbers. And when I have two even numbers, I know that I'm not in lowest terms. These are both divisible by 2. So if I divided 2 divided by 2 is 1. 6 divided by 2 is 3. So my final answer for this one, 5/6 minus 1/2 is 1/3. Okay, remember, always look at your answer, always, and make sure that it's in lowest terms. In this case, it is not. This is something you're going to have to ask yourself every time you do a problem. Could I reduce it any further? All right, 4/7 minus 1/3. When I come down to make my common denominators, I think they'll both go into 21. There again, you can just multiply them. So to get from 7 to 21, I did times 3, which means I have to do times 3 up here. 4 times 3 is 12. So I know 4/7 and 12/21 are equivalent fractions. For this fraction, 3 to 21 would be times 7. So this is 1 times 7 is 7. Now I have like denominators, so I'm just going to bring it over, and I'm actually ready now to do my subtracting. 12 minus 7 is 5. Again, 5 is prime. So I know there's nothing else that goes into 5 but 1 and 5. So this is in lowest terms, 5/21. So 4/7 minus 1/3 equals 5/21. All right, one more problem before I turn you loose. 1/2 minus 3/10. Now, when you look at that problem, you're thinking, that's backwards. But it's not. You have to remember we're dealing with fractions. We're dealing with parts, and you cannot look at the denominators and automatically think that this is going to be a larger number. When I look at these numbers, obviously I could do 2 times 10 is 20. That could be my common denominator. But I know 2 goes into 10. So I'm just going to have my common denominator be 10, which means no work here. Love that. How did I get from 2 to 10 here? It's times 5, which means I have to do times 5 here. 1 times 5 is 5. Okay, now I'm ready to do my work. I have my common denominator. I'm just going to bring it over. 5 minus 3 is 2. Look at that answer. Those are both even numbers. That tells me that 2 goes into both of those numbers. So I'm not finished. 2 divided by 2 is 1. 10 divided by 2 is 5. Now I'm finished. 1/2 minus 3/10 equals 1/5. Okay? Now, like I said, this was quick. On your notes page, you have 3 things I'd like you to do. The first 2 are very simple subtraction problems with fractions. Notice they do not have common denominators. They're not like fractions. They have to be like fractions before you can do your subtraction. On your notes page, I want to see the problem. Underneath it, I want to see your new fractions, your like fractions, and then your answer in simplest form. Lowest terms. Get it as low as you can for 1 and 2. Now, when you get down to part 3, this is what I'm going to call our challenge for today. Part 3 is actually a 2-step problem. Paul's dad made a turkey pot pie for dinner on Wednesday. The family ate 4/8 of the pie. On Thursday after school, Paul ate 2/16 of the pie for a snack. What fraction of the pie remained? So we want to know what's left of the pie. Before we can know what's left, we have to know how much they ate. So just to give you a little hint, you're going to have to add up how much they ate first and then subtract it from the whole. Okay? And the whole is going to depend on whatever you choose as your common denominator. Remember how to make a whole. A whole, 8/8 is a whole. 15/15 is a whole. 12/12 is a whole. So when we talk about taking it away from a whole, whatever your denominator is, you need to make your whole based on that. Okay? This is not hard if you think about it and you take your time to do these steps. But the main thing with today's lesson is just like with adding fractions with unlike denominators, you have to find the common denominator first and make them like fractions. Think about it. When we ordered fractions, when we compared fractions, everything we've done so far with fractions, you have to have the denominators the same before you can even work with them. And the reason for that is when you think about fractions, you are working with parts of a whole. You cannot compare parts of a whole that are different, different parts of different wholes. They have to have something in common. Remember we talked about comparing apples to apples and apples to oranges. We have to always compare apples to apples, like denominators. All right, do well on this page and come to class tomorrow with this filled out completely and neatly so it can be graded. And we'll see you tomorrow.